For nearly a century, astronomers believed they had solved one of the universe's greatest mysteries. Every galaxy, from tiny dwarf systems to enormous spirals like the Milky Way, seemed to be held together by something invisible, something that couldn't be seen through telescopes, couldn't be touched, and had never been directly detected. They called it dark matter. Scientists estimate that dark matter makes up about 85% of all matter in the universe. Without it, galaxies should simply fly apart. But then, a small, faint galaxy nearly 65 million light-years away appeared to break every rule. When astronomers measured its motion, they found something impossible. It looked like a galaxy, but almost none of the dark matter was there. At first, they thought the instruments were wrong. Then they checked again and again. The numbers refused to change. If this tiny galaxy truly existed without dark matter, one of astronomy's biggest ideas might need to be rewritten. This is the story of the galaxy that challenged decades of scientific belief. For decades, dark matter wasn't just another theory, it was the foundation of modern cosmology. The idea began in the 1930s when astronomers noticed galaxies rotating far faster than visible stars alone could explain. Later observations confirmed the mystery repeatedly. Stars at the edges of galaxies moved so quickly that gravity from ordinary matter shouldn't have been enough to keep them in orbit. Something invisible had to be adding extra mass. That invisible ingredient became known as dark matter. Although scientists have never directly detected a dark matter particle, its gravitational effects appear almost everywhere in the universe, from galaxy clusters to the large-scale cosmic web. By the early 2000s, dark matter had become one of the strongest models in astrophysics. Then, a tiny galaxy entered the story. Its name was NGC 1052 DF2. Discovered using the Dragonfly telephoto array and later studied with the Hubble Space Telescope and the William Keck Observatory, DF2 didn't look especially unusual. It was large, but extremely faint, containing relatively few stars spread across a wide area. Initially, astronomers expected it to behave like every other dwarf galaxy. Instead, its stars told a completely different story. Scientists measured the speeds of 10 bright globular clusters orbiting inside DF2. Normally, if a galaxy contains large amounts of dark matter, these clusters move rapidly because of the galaxy's enormous hidden gravitational pull. But DF2's clusters were moving surprisingly slowly. So slowly, in fact, that the visible stars alone seemed capable of explaining nearly all of the galaxy's gravity. The calculations suggested something astonishing. DF2 appeared to contain little or possibly no dark matter at all. If true, it would become the first known galaxy where ordinary matter dominated almost completely. That wasn't supposed to happen. According to the standard model of galaxy formation, galaxies are believed to grow inside massive halos of dark matter. Without those halos, many astronomers argued, galaxies shouldn't even be able to form in the first place. Yet DF2 seemed to exist anyway. The announcement immediately sparked one of the biggest debates in modern astronomy. Some researchers believed the measurements were incorrect. Maybe the galaxy was much farther away than originally estimated. If its distance were wrong, its size, brightness and mass calculations would all change. Others questioned whether the globular clusters truly represented the galaxy's gravity. Could they simply be moving in unusual ways? Teams around the world began reanalyzing every observation. The Hubble Space Telescope collected more precise distance measurements. The Keck Observatory gathered additional spectroscopic data. Independent researchers repeated the calculations using different methods. Instead of disappearing, the mystery became even deeper. Evidence continued pointing toward the same remarkable conclusion. Somehow, this galaxy appeared to exist with dramatically less dark matter than expected. And as scientists searched nearby space, they found something even stranger. DF2 wasn't alone. Another neighboring galaxy seemed to show the very same impossible behavior. If two galaxies lacked dark matter, perhaps this wasn't a measurement error after all. Perhaps nature had revealed an entirely new class of galaxies. Or perhaps astronomers still didn't fully understand how galaxies are born. The discovery was about to force scientists into one of the most fascinating investigations in modern astrophysics.
The second galaxy was called NGC 1052 DF4. Like DF2, it appeared to contain far less dark matter than astronomers expected. Finding one unusual galaxy could have been dismissed as a statistical fluke. Finding two orbiting the same giant elliptical galaxy demanded a deeper explanation. Scientists now faced a difficult question. Were these galaxies born without dark matter, or had they somehow lost it? One leading idea involved a process known as tidal stripping. Imagine two galaxies passing close to each other. The immense gravitational pull of the larger galaxy can stretch and tear apart the smaller one, pulling away stars, gas, and possibly its surrounding dark matter halo. Because both DF2 and DF4 are close to the massive galaxy NGC 1052, some astronomers proposed that powerful gravitational interactions had stripped away much of their dark matter over billions of years. Computer simulations showed that under very specific conditions, this scenario might be possible. But there was a problem. The simulations required an extremely rare sequence of events, and not every observation matched the predictions. Some researchers argued that if tidal stripping had occurred, the galaxies should show more obvious signs of distortion than were actually observed. The mystery remained unsolved. Another debate centered on something surprisingly simple: distance. If DF2 were significantly farther away or closer than originally measured, then its true size, brightness, and mass would all change. That could alter estimates of how much dark matter it contained. Astronomers used multiple independent techniques, including observations from the Hubble Space Telescope, to refine the galaxy's distance. While different research groups reported slightly different values, later measurements generally supported the original conclusion that DF2 is about 65 million light-years away. The uncertainty narrowed, but the questions did not disappear. Instead, scientists realized that the universe might be more complicated than their models had assumed. Perhaps the most important lesson from DF2 and DF4 wasn't that dark matter doesn't exist. In fact, overwhelming evidence from galaxy clusters, gravitational lensing, the cosmic microwave background, and the large-scale structure of the universe still strongly supports the existence of dark matter. These galaxies did not overturn that evidence. Instead, they revealed something equally valuable. If galaxies can exist with very little dark matter, then dark matter and ordinary matter are not always locked together in the way astronomers once believed. That distinction is critical. It gives researchers a rare natural laboratory for testing competing ideas about how galaxies form, evolve, and interact. Sometimes the greatest scientific discoveries aren't the ones that confirm a theory. They're the ones that expose its limits. Today, telescopes around the world continue searching for more galaxies like DF2. New instruments, including the James Webb Space Telescope, are helping astronomers study faint galaxies with greater precision than ever before. Future observatories, such as the Vera C. Rubin Observatory, are expected to discover thousands of ultra-diffuse galaxies, giving scientists a much larger sample to compare. If more dark matter-poor galaxies are found, astronomers will be able to determine whether DF2 and DF4 are extraordinary exceptions or members of an entirely new population. Either outcome would reshape our understanding of galaxy evolution. Science is often imagined as a collection of answers. In reality, it advances through unexpected questions. A small, dim galaxy that almost escaped detection forced astronomers to re-examine ideas they had relied on for decades. Not because dark matter had been disproven, but because nature had revealed that the universe is more diverse than anyone expected. Some galaxies seem wrapped in enormous halos of invisible matter. Others may have lost most of it, and a few may have formed in ways we are only beginning to understand. The galaxy that had no dark matter didn't destroy one of astronomy's greatest theories. It did something even more important. It reminded scientists that every discovery is only the beginning of a deeper mystery. Somewhere in the darkness between the stars, the next impossible galaxy may already be waiting to change the story once again.